and related to that we have edge connectivity and vertex connectivity. So these two part we'll be discussing, and after that we'll have Eulerian path and Hamiltonian path, then shortest path problem. Okay, so one by one we'll try to cover. So for the time being we'll be starting with the term called cut set. Okay, so cut set with respect to edge, with respect to edges, and cut set with respect to vertex. Okay, cut set with respect to vertex. So once these two terms are clear, then we can move on to this connectedness concept. Okay, so let's get started with this cut set. What is actually cut set? So what is cut set? See, cut set with respect to edges. First, see the definition. What is cut set? Cut set, it is in a connected graph, in a connected graph G, a cut set is a set of edges whose removal, see this term, whose removal from that graph G, leaves a disconnected one. Okay, that means if you remove that part, then G becomes a disconnected graph. Okay, provided removal of no proper subset of these edges disconnects G. That means it should be the minimal choice. Okay, so whatever part you are removing, that should be your minimal choice, and after you remove that part, then the graph becomes a disconnected one. Okay, that is the meaning. So through this example we'll try to understand this concept. See, first draw this graph. See, here you have this edges, okay, and the corresponding vertex. You just draw this clearly, this along with this. Okay, so just give the labeling. Suppose this is vertex 1, this is vertex 2, this is vertex 3, this is vertex 4. Suppose here you have another vertex, and this is connected with this is connected with this one connected with this, and this one connected with this. Okay, so here you have this 5, and here you have 6. So here you can put the labeling of the edges. So this is suppose A, edge A. Okay, here this is B, this is C, this is D, this is suppose E, this is the part F, this is G, and this is H, this is I. Okay, suppose this graph we are considering. Now in this graph, can we say that A, F and G, can we say this is a cut set with respect to edges? Can we say this? See, A, F, G, if you remove this A, F and G, if you remove these three, just see what you are going to get. If you remove this, so if you remove this, see, you remove this part. Okay, you remove this part and you remove this part. See, this curve you are getting, okay, or this graph you are getting, which is not at all a disconnected graph. So this choice, it cannot be a cut set with respect to edges. Okay, first thing you should get a disconnected graph. Okay, then you can check whether it is a minimal choice or not. So this is not a cut set. Okay, fine. Now you can take another example, the check whether it is a cut set or not. Now suppose I am considering a comma I. Suppose a comma I we are taking. So check whether this is a cut set or not. Check a comma I. Now suppose you are removing this one and this one. See whether this is a cut set or not. So you are removing a, this edge you are removing, and this one you are removing. See, yes, you are getting a disconnected graph. Yes, this is one portion and this is another portion of the graph. It is a disconnected, but is it minimum choice? Just think, it is not minimum choice. Why? Because see, you are unnecessarily removing this a, this edge, you are unnecessarily removing this part, because if you simply remove this part I, then it is okay, sufficient for you to get a disconnected graph. So this is not a minimal choice. So from that context, this is not a cut set. Okay, I think it is clear. So now see, this is not a cut set because this is not minimal choice. This is not minimal choice, although it is giving you a disconnected graph. Okay, now see, this is not a cut set because it once you remove this part, still you are getting a connected graph, so it is not a cut set. Now suppose if you remove simply I, if you remove simply this part, see, if you remove this, then what you are getting, see, if you remove this part, you are getting a disconnected graph, and yes, it is a minimal choice. Okay, less than I, that means I is the only choice here you are taking. Okay, so this is a cut set with respect to edges. Okay, so this is a cut set with respect to edges. Okay, now if I just give you another example, suppose check whether this set, suppose this set D, E and F, whether this is a cut set or not. This is a cut set or not, D, E, F. So check this and try this question by yourself. Okay, check whether this is a cut set or not. Okay, that is the concept of cut set with respect to edge. Now see, D, E, F, D, E, F, that means this one and this one. If you remove, see, D, E and F, if you are removing, not a problem, still the considered curve or considered graph, it will be a connected graph. So this cannot be a cut set. Okay, so likewise you can take set of edges and check whether that consideration it is a cut set or not. Okay, now see, when we consider this connectivity concept, then each of these, I'm removing to I'm going to the next slide. I'm not removing this part. Later on I will share this entire whatever I am writing here, entire write up I will share as a note. Okay, so I am moving to the next slide. See, connectivity, if we consider this connectivity, each cut set of a connected graph G consists of a certain number of edges. See, number of edges in the smallest cut set. Here this is a one important point, number of edges in the smallest cut set is defined as edge connectivity of the graph. Suppose the graph is G, of the graph G, and it is denoted by lambda of g. Okay, so this is the concept of edge connectivity. Okay, so now if I consider a few example, suppose this one, suppose this graph I am considering, this graph. See, when I give one question, you should try that question by yourself first. Okay, later on you can come back and verify your solution. See, if we have this graph, suppose the vertices are, suppose A, B, C, suppose A, B, C, D, E and F, suppose this is F. Okay, so this is your graph. Now find out edge connectivity. See, if you remove, suppose if you remove, see, your target is to get a set of edges whose removal produces a disconnected graph. Okay, this is the first criteria. And second criteria, that set should be a minimal choice. Okay, now see, if you just simply remove this, suppose remove this and this. Okay, suppose if you are removing these two, then see, you are getting a disconnected graph. And see, this edge and this edge, out of these two edges, if you are just simply keeping, suppose this edge, still you are getting a connected graph. So in that case, removal of these two edges giving you a disconnected graph, and as well as this set, it is a minimal choice. So you can consider this, see, these two edges, okay, these two edges as, what is the edge here? Suppose you consider CD and DE. If you remove this part, then you have a disconnected graph, and this is also a minimal choice. So this is a cut set. Okay, this is a cut set, and you can observe from this entire graph that this is the smallest cut set you are having. Okay, this is the smallest cut set you are having. So in that case, if you just denote this graph by capital G, suppose G is this graph, then lambda of G, in this case the value should be 2. Okay, so lambda of G, the value should be 2. Clear? Now see, this is one example. This is, suppose, example that previously I considered one graph. So this is example 2. Now suppose I am considering another example, example 3. Suppose this is the next graph you are having. From here to here, this, from here to here, this is another part. Here you have this. From here you have another, this. Now from here to here you have this, and they are also connected. So here they are connected, this part is also connected. Okay, so just give the vertex A, B, here you have C, here this one is D, E, F, G and H. Okay, so if you consider this graph, just think that which part, if you simply remove, then the entire graph, it becomes a disconnected one. Which part? Just think which part you need to remove so that it becomes a disconnected graph. After that, you need to check whether that is a minimal choice or not. See, you can pause this video and try it by yourself. You will see that this part, if you simply remove this BE, this edge, then it becomes a disconnected graph, and it is also minimal choice. and in fact this is the smallest cut set you are having. So in that case, this set BE, this is the smallest cut set you are having. So lambda of g, if you just denote this graph by g, so in this example lambda of g value will be 1. See, lambda of g, because this is the smallest cut set you are getting. Okay, so lambda of g value will be 1. So in that case, this is your smallest cut set. See, in such case, when you have this lambda of g value 1, then this particular edge, it is called as bridge. Okay, bridge, this is called as bridge. So this term you should know. What is bridge? Okay, if in a edge connectivity form, if you are getting lambda value 1, that means you will have only one edge in that cut set. So that set, that edge actually known as bridge. Okay, just think this edge, it is acting like a bridge. It is connecting this part with this part. Okay, so that is the concept of cut set with respect to edges.